So this lesson's about the idea of where trigonometry comes from. Trigonometry is a branch of mathematics that connects or establishes the relationship between the side lengths of a triangle and their angle measures. So it's a pretty neat thing because typically those two don't have a lot in common, but trigonometry is like the bridge that connects the two. So here's the idea behind trigonometry. Mathematicians realized that when you had the ratio of, say, like a shorter leg to a longer leg of a right triangle, when that ratio was a certain value, they knew what the angle measure was of the angle opposite the shorter leg. So for example, when the ratio was a 3-to-5 ratio, meaning that one side is 3 and the other side is 5, that the angle measure is 31 degrees. And that's true regardless of the size of the legs of the triangles, as long as they're in a 3-to-5 ratio. Like this second one here, the ratio is 9-to-15, but that reduces to 3-to-5. The same one in the third one with a 6-to-10 ratio and even 33-to-55. As long as it's a 3-to-5 ratio, that angle is always about 31 degrees. So that allowed us to figure out the height of a tree. Because what we could do is if we could start at the tree, so here's our tree, and if we could go horizontally to make that right angle, if we go far enough back so the angle up to the top of the tree is a 31-degree angle, we know that the sides are in a 3-to-5 ratio. So what we could do then is we could write a proportion using similar triangles. We know that that ratio is 3-to-5, and that's going to equal something when we call this h for height, h to 36. And as long as we have that 31-degree angle, we know that ratio we can solve. 3 times 36 is 108. 5 times h is 5h. We'll divide both sides by 5, and we get the height to be 21.6. Now, it's not exactly 21.6 because the ratio is about a 3-to-5 ratio when the angle's 31. But think about as powerful as that is, think about the challenges that you'd face. How many different ratios would there be? So maybe it's a 3-to-5 ratio if it's a 31-degree angle. What if it's a 35-degree angle? What if it's a 42-degree angle? What if it's a 12-degree angle? All these different ratios we have to remember. So the branch of mathematics called trigonometry related angle measures and side lengths. And the ratio that we're talking about, the leg opposite an angle to the leg adjacent to the angle, we call that the tangent of the angle, and we abbreviate it TAN. You might have seen that button on your calculator. So let's show you how to solve this problem using trigonometry. Same diagram, 31-degree angle, but the tangent ratio is defined as the length of the opposite side to the length of the adjacent side of a given angle. So based on the 31-degree angle, the side I labeled h, the height of the tree, is the opposite side. And the side labeled 36, the distance along the ground, is the adjacent side. So this is the equation that we could write to solve it. Now, this left side, tangent 31, it's a number in your calculator. And if you go to your calculator, and if you type in a scientific calculator, if you type in 31 and then press the tangent button, depending on the calculator, I'm using my phone right now, so I do 31 and then press tan. If you have a handheld, you probably press the tan button first, then 31. The tangent of 31 is a decimal. It's about 0.6008 and a bunch of other numbers. And you might recognize that 0.6 is what the ratio 3/5 is equal to. So it's really close. Now, to solve this, I'm going to have to do some cross multiplication. So my value of h is equal to 36 times this value, 0.6008, lots and lots of numbers. So when I multiply that by 36, when I multiply it by 36, I get h to be about 21.63 and a bunch of other numbers. So that is really similar to our answer of 21.6 that we got with the ratios. But this time, instead of worrying about what the specific ratio is, we use things like tangent.